Hello everyone, thank you for joining us for this Autodesk second webinar with Car Design News. My name is Eric Galina. As you know, this webinar will focus on technical surfacing, and with us we have Uwe Rossbacher, Product Manager for NURBS Modeling Technical Surfacing from the Manufacturing Solutions Division at Autodesk. Uwe has over 14 years experience in this field, so I'm sure he has a great deal of knowledge and expertise to impart. Before we start, I would like to remind all of you in attendance to draft up some questions which Uwe will answer in the Q&A session following this presentation. Please ask these questions by typing them into the box in the lower right-hand side of your screen. If you should happen to experience any technical issues during this session, please also type these into the Q&A box, and our team will do their best to sort these out for you. If you're using a PC, be sure to check that the audio is not in mute mode. I hope you'll find this webinar stimulating and informative. I'll now hand it over to Uwe so he can begin his presentation. Thank you.
Hello, my name is Uwe Rossbacher, and I'm going to start this presentation. And I'm just launching the document that I have, and we are good to go. What I will not do during this webinar is to recommend any software. I will avoid to criticize any software because I'm aware that there are several ways to model surfaces. I'm aware that there are several methodologies to achieve surface models, reasonable surface models, and I just want to give our Autodesk idea about freeform NURBS surfacing. I don't think that this webinar will turn the audience into Class A modelers. I believe that this is a kind of a long way. But this webinar should give the audience food for thoughts. This webinar should be an initial point for thinking about workflows and about development of skills. That's about it. This webinar will show differences in data structure between concept modeling data and Class A modeling data, and it will show some Class A methods to allow the audience to achieve some kind of surfacing quality standards that they probably want to achieve. The entire topic is around exploring shapes or developing shapes, and these shape development things, they can happen on several different phases during the design. Let's start with the beginning of the design development, and we see here that shapes will be created that are just standing for a kind of a new that is just standing for a kind of new design intention, and it doesn't have to be necessarily a shape of a car or whatever, just a kind of a form study. And this can be done using polygons, it can be done using a subdivision surface, and it can be done using a NURBS surface, which is the top key of this kind of with this kind of webinar. I want to concentrate on NURBS on NURBS surfacing with that. So, and next phase in the design development could be evolving or could be developing an existing theme. Here we use NURBS surfaces to take several existing themes and bring them down to 3D packages, bring them down to engineering requirements of existing platforms, or combine and to bring them a little bit more forward. can be done very well with NURBS surfaces, and these models are specific as well. And finally, we talk about the finish of or the finishing of the theme. And here we talk about surfaces that have to be ready for tooling. So these surfaces, they go into production, and they have to satisfy a certain standard. And this kind of standard can be specified, for instance, as Class A. And here we come into this mystical kind of term, Class A, because what is Class A? I figure that this is a question that many people have when I tour around the world with customers. Everybody's asking, what do you think is Class A? And it's very hard to find that common thing. Class A, at the end, is basically a bar. It's a measurement. It's a level that gives us an idea about the quality of surfaces. We have to see that this Class A term is very often used, and maybe even came up with the automotive industry. Because in the automotive industry, we have the potential, the economy potential, the monetary potential to allow users to accumulate knowledge and to even allow processes to have enough space to do Class A modeling. Class A modeling requires certain processes, certain efforts in staff as well as in logistics to be successful. This Class A term specifies a challenge from my point of view. The challenge is to combine beautiness of surfaces with engineering requirements. So what is beautiness of surfaces? This is totally relative. The beautiness of surfaces can be seen, for instance, in the it can be seen in the quality of the highlights, like in the picture that we see right now. But a surface that is just beautiful is not at all a Class A, so it's not needed that it's specified as a Class A surface set. Just when the engineering criteria will be met, then we can see, yes, it's probably a Class A surface. So the challenge here is the combination of both, the aesthetic point and the engineering requirement point. So to come to a model, to a good model that maybe at the end will be specified as Class A, we use, or I will introduce this webinar, I am introducing in this webinar, NURBS modeling. So I can see there are two ways to do NURBS modeling. One way, you can call this direct modeling. That's a very interesting way, because it is very close to what sculptors, what artists are doing with stone, what are they doing with, what do they do with wood or clay. They shape it like an amorphous material. In 3D computer modeling, the operator of the software would, instead of shaping the material, he would shape CVs, control vertices, control points. There are lots of words for these things, and the operator basically starts often with a flat surface. And then he pushes and he's pushing and pulling the CVs until he reaches the shape that he intends to reach, until he's happy. When I learned that method, I was told to see the underlying surfaces instead of the feature lines. So when you see a car, let's say a Porsche 911 for instance, it's very hard to not see the beauty and to not see the the highlight and the curvy surfaces, but to see the underlying patches. Because we are distracted and we are used to see the feature lines, how they follow. But in this approach here, we have to concentrate on the underlying surfaces and how to directly manipulate them. And that's why the word direct modeling. Another approach has something to do with artists as well, but more like artists will draw. When you try to draw a car with a pencil on a piece of paper, you will start with drawing lines. Very few guys are trying to outline with a brush kind of shapes, kind of surfaces, or explain the shapes with sections. Mostly they will lay out curves. That's what the procedure modeling method is doing as well. They can outline curves, and then they kind of hang in patches between the curves. They create a network of curves, and then they try to fill the network with surfaces. Typical procedural software tools have the ability to say one surface should be in a certain way continuous to another surface. They have their position, tangent, curvature, G1, G2 curvature, or G3 curvature, and all that stuff. I figured out over the years that, so I have to say, I'm coming from the direct manipulation thing. I learned to build a whole car, a whole surface model based on one flat surface. But over the years, I figured out that the combination of both makes me fly in the world of software, in the world of surface modeling, 3D surface modeling on computer. I'm used to lay out my primary surfaces, my slab surfaces, as simple as possible, as clean as possible, and as light as possible, using direct modeling methods. Then I finished the model with transitional surfaces coming from blend tools, profile blend tools, or fillet tools, which are tools from the family of procedure modeling methodology. So the combination of both brings success. And I talk to lots and lots of people. That's my profession. I'm traveling the world, talking with people, with you guys, and I can summarize that this combination of these methods is the way to go. Let me right now go into a software. I'm using Alias Surface 2010. I guess that will be a software that most of you guys at least have. And I will do a little bit of work into that. I'm sharing right now my application. And I hope you can see right now, I believe that you can see right now a gray model of a car. And that I downloaded that model years ago from cardesignnews.com. And it is a NURBS model of a car, like everybody can see. But for me as a surface modeler, this car has way too much details to be evaluated. For instance, this car has all the fillets and all the flanges that we can see over here. We can see it over here. So that is way too much for me to make a judgment about it. And I want to show you what I would do with such a model. So the first thing what I did to find a good judgment on a car, I came up with the relevant surfaces. And we can see here the relevant surfaces. These are surfaces that are with no fillet and that are untrimmed. I want to see the fillets, the surfaces in their pure appearance. And now I'm going to check what this surface model is about. So for this, I turn off the shading, and I am starting with a first kind of check. I like to see the half of the car, and I'm going to check the surfaces crossing the center line. Maybe this and maybe this surface. And there are a few surfaces here as well, so why not checking them all? And then turning off the CVs, and I can see that some surfaces are built across the center line and just trimmed back, and some surfaces are just half, which is a thing that would be okay, but probably we'll have here some issues. And I'm doing the next thing, what I'm usually doing with those cars, or with those models. I'm going for the symmetrical view, and I'm choosing here flat surfaces. So the trunk, the roof, that's enough, and the hood. And I'm calculating sections on it. And maybe here, the good thing would be when I calculate sections every 70 millimeter. I think that's okay. And I'm asking the software here for a curvature plot. And I'm raising that, and I'm doing a better tessellation tolerance. Good. Here we are. So what I see here from this view is that I have here a certain texture. I have here a certain characteristics. And I have here a different characteristic. And here I have a totally different characteristic as well. And so I would say in Class A, we cannot deal with that because we have to find a common thing. We have to find something that is balled. And how that could look like, I'm going to show that. I have here another model. It's over here. That's a real size thing. And what I mean with what I need to see, what I would like to see, is something like this. I'm doing exactly the same thing like I did before. I'm selecting some flat surfaces, and I'm selecting again as sections. Probably not every 70 millimeter, probably every 200 millimeter. That's enough. But what we can see is that the character is basically here kind of clear. I mean, I have always the same character over the roof, and I have almost the same character over the hood. So this model, a Class A modeler, could understand what the design wants to finish these surfaces, because there's a clear indication of what this model should be about. I'm coming back to the model that I started with. I'm turning off the symmetry. I'm coming to patch layout issues. I want to point your interest on these two surfaces and on these two surfaces, and I turn on the Cs for that. We can see that I have in that area here several shapes. Three. I have a flat shape, I have a flat shape here, and I have here a round shape that should combine the two flat shapes. And so it's the same over here. I have a flat shape, I have a round shape, and a flat shape. The problem here right now is when we come to Class A criterions, very often I probably have to change here that radius. I want to change it here a little bit. Even when it's a smaller detail in the car, I want to change it, but I cannot, because this is one surface here. And I have to change the entire surface, and that kind of surface dividing over here might be wrong, because maybe it is here, or it is somewhere. Basically, that flat thing and that flat thing and that round thing should be visible in the patch layout. Now you can say, yeah, But this modeling here, the surface, when I move that CV, nothing happens over here. When I move that here, nothing happens over here. That is right. But this surface is very heavy. I don't think that the heaviness is a big problem just because of the heaviness. But let me show you this. I calculate on this surface here sections. And maybe not every 100 millimeter, that's a bit too much. Let's say every 50 millimeter. And I get a section there. And I turn the section, the scale a little bit up. And then I do even here a finer tessellation. So basically what you see here is that the shape, regardless of that thing, I don't care so much for this. And we can debate that probably it's good, probably it's not good. But you see here along this way that that shape has several G3 breaks. That is not good at all. In Class A, or let's say in automotive account, you cannot deal with that. That never will be exact. So that surface cannot work in terms of the brakes, the internal G3 brakes, plus that the form is not correctly interpreted. I saw on the attendee list a couple of guys from the automotive industry, and they will confirm that. We have to interpret the shape, and there are three shapes, and I have to see the shapes in the patched out. I think that is the message that I want to give you guys. Good. So let's see what is the next thing. The next thing, what I'm going to do with those kinds of models, or with any model that I get when I get it, and I have to do something with it, I would like to know what kind of highlights I can see over this. And so let's say I get these two surfaces, and I use height unselect. I'm using right now no customization. So I want you to see where I get my tools from. So I'm using the palette. I'm using the evaluation tool, the ISO angle tool, and it appears always like that. So I go for multiple. I want to have much more. Probably I want to have 35. And I'm going for no shaded surface, but visual curves. And I say that I probably can hide the manipulator. Something like this. And that means that I can right now use in the viewing panel and the viewing the same thing. I can use a distorted view, and I can see what do I see here. And the highlights of the patches here, these are the major patches of the body side, are not good because they are clearly defined here.
Hello everyone, we're experiencing a bit of a technical issue here. Just bear with us, we'll try to get Uwe back on the line. Hope you're enjoying the presentation thus far. We apologize for this, but do bear with us and we'll be with you shortly.
I guess
welcome back.
Yeah, I'm back. Something happens with my line. So right now I'm going to share the application again, and I will go forward, right?
That sounds great.
Good. So, sorry for the inconvenience. Sometimes these things happen. So, to make a long story short, these highlights are not okay because they have too many characters. concave, convex, concave, convex, concave again. That's not good. So I would test that, and I would like to see that. I come back with perspective on, perspective off, and I can delete these visual curves as curve on surfaces, and I'm going to show you the rest. So, and right now I would like to show you another thing. I think it's a trick. Let's say we talk just with this curved surface, and that surface is an untrimmed surface. What I can do with that surface, regarding the fact that I don't like it with lots of spans, it doesn't matter yet. What I can do is I can go for object edit, and I can extend linear on, merge off, and I can extend that thing very long. So what I can see here right now is, from the side view, I can see that the first hull is pretty okay. It's concave all the way. But I can see that the second line, the second hull, is totally creepy. I'm sorry for the English word, but it's totally undefined. It's giving me something, which is a clear indication that in that hood here, this line here is something somehow wrong. You cannot see it because when you see probably this here, everything looks nice, and when you see the curvature comes, or maybe even when you see the Gaussian, everything is fine, everything looks good. So there is no problem in that. But there is a problem, and you can see that when you do. So it looks yeah. But finally, with the extrapolation, you can see it much better. And with this, I would love to open another file where you can see something more. And this is a file with a fender, and I want to point your interest on that surface, right? So that surface here looks nice. We do this, we do the vertical, no, we do this, and we put here a little bit more. That surface looks quite okay, right? When we look at the when we go for the drawing style and we want to see the surfaces, see it's a little bit different. Looks kind of okay. But what we really could do with that is we could say we go into object edit. In the extend tool, we go for linear on, merge off. We say we want to do this here, and then we want to do this on the other side. And now we can see that the first line, that line is pretty okay. But the second line is really zigzaggy, and that means I have a problem in that line. That CVs are not in conjunction with this. Same thing is with this here. That line is pretty okay, but that line is zigzaggy. That means that that line here doesn't work together with this one. How to correct that? I usually use an object edit. I'm using the align tool, and I'm asking for aligning that guy here. But use a tangent. And then I'm aligning this guy over here using tangent. And now this friend here is historical. So I can right now take this CV and move that CV. Very fine. You can move that CV, and that CV will be adjusted. I can move that CV, and so I'm able to adjust that surface. I'm able to adjust that surface with these helper surfaces to make that fitting, matching to this here. And I do the same thing on this side. With this, I'm able to do a very good kind of smoothing of the inner kind of things. So I'm going back into the NURBS car that we had at the beginning. And I would like to show here another thing. With these surfaces, let's say, I use a hide unselected object. I just don't want to see this. And when we see this here, and I even use non-perspective, I can see that line here, right? It looks concave. I turn it a little bit, it looks almost flat, and then it looks convex. Pretty good. I can even see that when I go for locator, for this, and I check here, and I can see that curvature locator, I'm using the middle mouse button and then the right mouse, the left mouse button, and I can see that curvature button is pretty straight. Here it's a little bit, but that's okay. That is pretty good. But when I see this here, this looks really wavy. So that looks here convex, concave, but I cannot find a point where it looks straight. When I watch it from a view here, I can see that the curvature plot is really waving, which is something what we don't like. We would like to find clarity. We would like to find harmony. When it goes from convex to concave, it must be flat somewhere. How does it? How would be something, or what could I expect here? Or what do I mean here? Let's say we take these two surfaces, and I say hide unselected object, and we can see maybe that line here. That line is straight, it's convex, concave, and straight. So when we do here a curvature plot on it, we can see that the curvature plot is on a plane. We like that. That's harmony. We like that class A because then we have a defined character with a defined shape that we want to go for. And that is something that a class A model or a class A modeler would look for. And these are, let's say these are the first things I would look for when I see the car. Let me go back to this kind of presentation, and I will look more into the Class A thing. Mr. Barry Hale, a guy from England, in 2009 he left some words at an automotive day in Munich about Class A. And Mr. Thomas Saline, at this time he was the digital design manager at GME, he brought this kind of definition for Class A. The big point here is that he says that Class A modeling or good surface modeling is based on the knowledge and the skill set of the individual user. So the whole thing is user dependent. So a software is not a guarantee for Class A. You need the skill set and the experience of the user, which is, from my point of view, the biggest thing. That's why I'm talking to you, that you understand that we have to work with your users. You have to work as a user to achieve the skill set, the knowledge that is necessary for Class A. Good. Let's talk about the topic with tolerances. Here we have something that is very important because all of you work probably for this TV5 or for UGNX 0.001 millimeter gap tolerance. So please look at this. When we go for a file like this, and we have this here, and you want to fill that here with a surface, you probably would do it like this. You would go for square and say 1, 1, 2, 3, and 4, and you get a surface here. So you can see there are a lot of bands and a lot of weight. I go for fixed here, and believe me, I want to shorten that. I can play here with what I want, but it will always be with lots of CVs. Not a good idea. especially when we work for of 0.001. So what you could do is this. Yeah, I have exactly the same thing. So you could say you do here an untrim. And you say you create an edit point curve from here to here. And in 2011, things will change. But in this version, you go for that align 2008, and you go for line second, and you ask first the curve of surface, then the curve, and then you ask for explicit control. So you will get a curve like this. Then you ask for a locator, and you ask for the deviation between the curve and the curve on surface, and that is roughly 0.6. So you go with the curve much better. So you give them, let's say, 6 CVs. So you go for 0.0017, which is okay. You go close. That's everything what you need to know. You just go close as you can. So and then we delete the curve on surface, the old curve on surface that we don't need. And then we have a surface here and the curve here, and we ask for hide unselected objects. We go for the side view, and then we untrim that surface, and then we take the curve that we just created, and we say we duplicate it, and I put the pivot there, and I put it in here. There's a nice tool here that says curve stretch, and I put here the white ball in it, and I put it in here. And now I'm going back to my align tool, 2008 align, and I ask second. I ask this guy and this guy, and now we will calculate, and I ask for partial for partial fatigue joint. So I get surface like this, a curve like this. And now I'm using here the possibility to slide, and I'm sliding that down. I don't like this here. I'm sliding that a bit down and invoke the history. Sliding that down. Invoke the history. I'm sliding that much more down. So these two curves looking pretty okay. So I take these curves, I say hide unselect object, and I do a skin between these two curves. Between this and this. It's clean. It's a very clean skin. And I'm even asking for just degree 1, that I get a very defined clean skin. So then I use the curves and I delete them. And then I say I want to see everything, and I trim that surface again. So what I have now is this. There is no curve on surface here. No curve on surface. So what you do is you use the new align tool, and the new align tool has here edge and project. Edge is when I would have a curve on surface here, but I don't have. I use project. I'm asking this guy to this kind of surface, and I like, because it's I like it from this direction, and I'm going for 7. Oh, he's not doing that, and then probably I'm going for 1 span, and I'm able to do it here, and then I'm giving here an explicit control thing, and I'm giving here a curvature thing with that, and I have here a clean surface set that works with that wheel opening solution. So I have this thing here, and I have it here. That works pretty good with a tolerance for 0.005 dV5. Yeah. When I go here for the next thing is, I don't show it in the software now because of time issues. I'm running out of time here. When you have two surfaces, this surface and this surface, and you need to make a fillet, it could be that when you just do that fix, that you get a trumpet-like fillet, or you get a quarter fillet, but with fat highlight, small highlight, and fat highlight, small highlight, and small highlight. That's not very good. You shouldn't do that. It's because the angle between here and between here gets not correctly interpolated. If you want to do that, you have to use tangent angle for this edge and for this edge. If you want to do that, then you see here a correct interpolation from here to here, and that would result in a fillet, in a variable fillet, but which is clean, or with a quarter fillet which has clean sizes of highlight, which is necessary to have a clean and beautiful model. So what I want to say, the fillets are dependent on the base surfaces. When you make a problem in the base surfaces, you never ever be able to reach a good fillet. That means when you do a concept model, you have to make sure that your base surfaces are good. Otherwise, we have to do everything again, and that is not good in terms of the process in a car manufacturer. So let me come to the summary. In this webinar, I wanted to show you that there are differences in data structure. When I see a concept modeling data set and a Class A modeling data set. And these differences are that in the weight of the surfaces, in the number of spans of surfaces, and I call it theory modeling. It is that the form is correctly visible in the patch layout. So flat, curved, flat. Then I want to see, we have to see three surfaces, not just two. And that webinar showed as well Class A methods that can be used to achieve this kind of modeling thing. I showed you using the align thing for handling light tolerances. I showed you that you have to have a good foundation for fillets in order to work with aligned tangent. And I showed you the trick with the extrapolations, that you can pull and push, or that you can pressure a surface between two flat extensions, and with that you can control the surface. And then last but not least, or no, that's not true. At the end, I want to say always try to build an intersection, that your patch layout will always be the character, will always be in accordance with the character of the shape. Flat, curved, flat. That has to be there with three surfaces. This kind of thing, I'm at the end of my presentation. And as Eric said, we are very much open to answer your questions.
Okay, Uwe, we did receive a couple of questions come through. The first question was, why do we have to model Class A standard when the final services get tessellated for tooling or even overcrowned anyway?
That's a very good question, and I'm a bit afraid to answer that. But I'm trying this. When we do clean modeling, and Class A modeling is clean modeling, we can save time with problem areas, with magic corners, where two radii come together, with all that stuff. We can save time there. I guess that a lot of the people in the audience, they experience it. They built a model, and it was almost done, and to really finish it, they had to spend another 4 or 5 days for that dirty corners. The other thing is that in a big corporation, I think it's good when a software model is, or when a data model is readable, so that one operator can go for vacation or can go for sickness or whatever, and another operator is able to read the surfaces and to work with the surface set that his colleague left behind. That's why I think modeling standards like Class A would be a good thing to go for.
All right, well, thanks for that, Uwe. There's another question that's just come in. Why is the tolerance to be kept 0.001 in most cases? Can you answer that one?
Yeah, I can answer that, but just to make sure, please, can you repeat the question, please?
Yes, certainly. Why is the tolerance to be kept 0.001 in most cases?
Okay, I can answer that. The first answer, I answer in 2 steps. The first step is because CATIA and UGNX, they require these kind of tolerances. And especially when I work with a combination of the OEM and the supplier, the OEM sets certain standards that the supplier has to fulfill. There's no discussion about that. When I'm just talking within the OEM, then I can see several cases, and I cannot name them right now because of NDA issues. I can see several cases where the tolerance is not 0.001. The tolerance can be held at 0.02 because within a company, within the workflow, when you can control the workflow, you are able to even import surfaces to CATIA V5 with lower tolerance standards. So, in summary, the answer is when it's supplier OEM, it's a requirement, it's a hard requirement, and when it's within the OEM, we can talk about that. I just showed that here as a common base that everybody can do it. It's possible. It's probably not always the best thing, but it's possible.
That's brilliant, Uwe. Thank you. We're kind of short on time, but I think we should go over this last question that's come in, which is there any written material for Class A modeling that you can recommend?
Basically, my basic answer is no. I know about the book in Korea. Don't ask me how to find it. I know in Korea there's a book in Korean language that contains it has just pictures showing how to model a car in a very good standard. That's a material that I know. I know material that is available on the Autodesk, on the Alias Design website, where we can find those workflows. And I know that we do sessions, for instance, at the Automotive Day. Okay, that's not for Asia, but in Europe we have an Automotive Day, and we have the same thing in North America. And there are several sessions in Asia as well where we try to teach those things. But no, I cannot recommend a book, or I cannot recommend any written material because there is none, except what I just said.
All right. Well, that's unfortunate. There's no web link either that you just said. Yeah. So that was one of the questions we had come through. But there's one more question then. What are the most common errors you have seen in data models, which you believe are the results of bad foundation surfaces? Can you answer that?
Yeah, I can answer it, but please, can you repeat the question? Because I could hear all. Yeah.
Okay, no problem. What are the most common errors you have seen in data models, which you believe are the results of bad foundation surfaces?
Okay, I have seen that in, definitely I have seen that in Class A departments in the car industry, in the entire car industry, but in Class A departments, where the design is almost finished and they do surfaces ready for tooling. I have seen that in I have seen that in consumer product companies, like Gore, that's a German company doing stuff for the bath tubs, and I don't have the English word for that, but that has to be chromed, and I have seen it in Apple. I have seen it in Frog Design, and I've seen it in a couple of industrial design companies who can afford a kind of an automotive workflow to achieve this kind of quality. But mostly it's with automotive companies and their Class A departments. I personally worked at the German car manufacturer, and we did this kind of work there even in the concept studio, because we can see that more and more every company tries to push us the time when we start with good surfaces forward and forward and forward, because they want to they want to avoid to say, oh, by the way, right now we have a design freeze, nothing can go anymore, and now we do the Class A. They don't want to do it. They want to have more time for design changes, and that's why they have to start with good surfacing much earlier.
Thank you very much, Uwe. Listen, unfortunately, we've got a lot of other questions. We'll have to answer them individually because we've run out of time. I'll leave you with this last question before we wrap it up. A gentleman wants to know, is there a training center in Holland or some companies that work with Alias?
There is no training center in Holland, but I have contacts in Holland who can do that. So this gentleman can be helped, but I need to talk with him directly. But there's no official training center in Holland, no. But when this gentleman is contacting me, I can help. Okay, very well. All right. Well, thanks very much, Uwe, for your presentation. I really did find that extremely informative. And I just wanted to thank everyone for joining us today as well. This webinar will be uploaded into our archives and accessible in the future for all of your colleagues who haven't been able to attend the live presentation today. You can access this and any of our previous webinars under the Process tab on the Car Design News homepage. So thanks again for joining us today, and I hope you'll join us again for our next webinar. Thanks very much, Uwe. Bye-bye.